Well, hello everyone, and welcome to Rail Day 2025. What you are seeing in your camera view is Juan, who is in New York, about to start the proceedings. They're waiting for people to get up the elevator, and we're very happy to have those of you online. So, Juan, turning it over to you.
So just a bit of introduction. Let me introduce all the people on the phone. So Scott, if you want to unmute your phone, your computer, and quickly introduce yourself.
Yes, I'm Moses Scott. I'm happy to join you remotely from Chicago, and I'm a co-chair of the Building Smart USA Rail Committee, and so I'm glad everyone can join and looking forward to the presentations today.
Thank you. Tony, do you want to introduce yourself quickly?
Oh, hi, I'm Tony Ranella with Building Smart USA. My colleague Janice Doe and I are just here in the background running the systems so that you can all appreciate the great work that Juan and Moses have done, bringing together some very exciting speakers and organizing some great conversation. So we'll be back here, and during the question and answer period, you may see texts coming from us offering to open your microphone if you're attending remotely, and even turn on your camera so that you can interact directly with the panelists. We know it's going to be a great day. Hope you enjoy it.
Thank you, Tony. Janice, do you want to connect your camera quickly and say hello? And both of you are going to be in the background, but you are an important part of this event. So,
okay, I'm a little camera shy, but I'll say hi. Hi, everyone. Yeah, we'll be back here. So if you have any questions, people online, just chat to us and we'll be happy to help. Very excited about today.
Fantastic. Thank you very much. So I'll introduce myself. I'm Juan Serrano. I'm Associate Director at Arup in the New York office. I joined the Building Smart Committee almost at the beginning, Rail Committee almost at the beginning, not at the beginning. Scott is the founder of the committee. The committee was built in 2014. I joined in January 2024, and I joined January 2025. So the committee is less than 2 years old. This is the second event that we organized for the Rail Day. The first one was organized in the back of the Highways Committee. So it was easy to organize because we have a lot of teaching support from our colleagues. This year we are flying along. This is the first time that we organize a separate event in a different location. So it's a bit of a nose territory for us, right? Right. So we're going to quickly review the agenda. So the first I'm going to hand over, after this brief review of the agenda, I'm going to hand over the mic to Scott, and he's going to go through introductions. But today we have the presentations split in 3 different blocks. In the first block, we are going to talk about projects in China, digital engineering certification in China. We are going to talk about a strategic implementation of ISC and model delivery from Autodesk. We are going to talk about the rail business and ISC use on the rail business in Spain through ADIF. Then we will make a break for lunch. In the afternoon, we will talk about the first presentation is going to be done by Autodesk. It's going to describe or introduce how IFC is being adopted in Sweden, in the rail business in Sweden. We will have fellows from Canada presenting their approach to digital twin, how they're trying to build a digital twin of all the Canadian properties. Michael Thomas Kinney in the room. He's going to present us. It was the third rail for Alexandria. Fourth rail, yes. Oh, good time, perfect. We will do a 15 minutes break for a couple of coffees and sodas, whatever we want to take, and then we will have another presentation in the afternoon. So we'll present the the approach to digital twins by NTA in New York, right? So with further delay, I'm going to hand over the mic to my colleague Scott, and he can go through the intros.
Thank you, Juan. Are we able to advance the PowerPoint? Great. Welcome everyone. I'm very excited that everyone can join us in person and online. I see we have a good number of attendees. As I mentioned before, my name is Moses Scott. I work at SNHA, which is a Woolpert company. We have our offices in Chicago, which is my headquarters, but also offices in several countries around the world. And we are an architecture, engineering, and geospatial company. But more importantly today, as I mentioned before, I am co-chair of the Building Smart USA Rail Committee. What I'd like to do in a quick 5 minutes is actually give a little bit of an overview of what we did this year. Firstly, we are a Building Smart international organization. Building Smart is a very unique organization, being that it is open, neutral, nonprofit, and it's an international standards organization, often submitting standards that we work on to the ISO Committee for Adoption for acceptance by private and public organizations around the world. Building Smart has over 36 international chapters. The USA chapter is one of those 36, and actually it's been around for 3 decades now. As we enter this discussion, Building Smart standards have been adopted as policy in many countries around the world. And also there's a Building Smart International Railway Room, which we are learning from as they have charged forward in creating IFC 4.3 definitions specifically for rail. Next slide, please. So a quick review of what we accomplished this year. As Juan mentioned, we started in the USA in the year 2024. A big motivation behind that was the Rail Manifesto for IFC 4.3, where several, well, actually 9 international bodies representing countries around the world, especially in Europe and China, created a manifesto for the adoption of IFC in their respective industries. And so that was a big part of that. We also had Rail Day 2024, and a big part of Rail Day 2024, which was in Chicago, was a call to action, which resulted in the creation of the Rail Committee in the Building Smart USA chapter. And then going on from there, I'm very glad that we were able to bring on Juan Serrano as co-chair of the Rail Committee. Around Q2 of this year, we stood up a Miro board called the Digital Expedition. And there's a QR code on this slide where you can go directly to that Miro board. It's organized around the initiatives we have for the Rail Committee. And an important function of it is that we can introduce ourselves to each other, get to know each other, and we use that to organize our calendar and our monthly meetings. So going into the next item, we kicked off regular meetings. These meetings occur once a month at the end of the month, and they've been developed their own cadence. And then finally, we're here at Rail Day for 2025. That's a typo, 2026. We're here in Q4 2025 for Rail Day. I would say that the emerging strategy that we've developed over the year is I would describe it as learning globally, but anchoring locally. So, part of that is that, we're gonna have our anchor in New York, but also meet globally. So going into that, some of the lessons that we learned was what's taken a part of the Rail Manifesto, how IFC 4.3 helps when applied to projects, helps build sustainability and transparency, and especially interoperability, and gets our projects away from being vendor locked in. And also ISO 19650 is an important baseline, and how openBIM can be used for our projects. But there's also a local reality that we learned from Rail Day in 2024. And some of that is being in the USA, there's over 80 rail transit agencies. It's hard to get all of them to work together and get on the same page. And that's one of the goals of the Building Smart Rail Committee, to start to tie the fragmented environment together. And so some of the things that we came out of the monthly meetings was, we repeatedly heard from our committee members, hey, we want to do this, but how do we do it? How do we get started with implementing IFC? How do we recommend to our project leaders and our companies how to adopt openBIM standards? And so another thing that we heard was there needs to be specifics for USA Rail, need for domestic property sets that's taken up into the IFC schema. Next slide, please. Oh, I'm sorry. I'm sorry. So yeah, so that is the end of my introduction. Part of what we're going to have today is that we're going to have great presentations from speakers around the world, which give examples of implementing IFC from the global perspective. So this is a great part of what we have set up for today, is that continuing this digital expedition of learning globally and anchoring locally. So we can take these global lessons, see what we can learn, and move forward into 2026. So with that being said, I'm going to turn it over to our next presenter. I'm going to call him Matthew, his English name Matthew, and we're going to play the video of his presentation, and then he's with us live to answer for live Q&A after the presentation. So with that, we'll get started, and I'm very glad that you can join us.
Sorry, this won't be a live event if there is no technical issues.
Today, I'm going to introduce to you our project, Multi-Domain openBIM Digital Engineering Certification and Handover for JiuQuan-Ejina Railway. Today, my introduction involves the following three parts: project overview, openBIM outcomes, and after using openBIM. First of all, let me present an overview of our project. As you can see, this is a railway construction project, and the whole railway links two major cities. One is a vital satellite launch center in China, and the other one is a famous tourist city with beautiful polar forests. And also, this railway project is part of the Belt and Road Initiative and the China-Mongolia Economic Corridor. And the entire railway project spans 243 kilometers with a construction period of 30 months. Our pilot project is based on this railway. It mainly involves communication, signal, power, and other measures in the railway industry. As we all know, BIM technology has been widely used in many industries. In the construction stage, equipment factory, design institute, and construction enterprise, they all use BIM technology to create digital assets such as digital equipment, digital design, or construction engineering. However, these digital assets are lacking uniform standards, which makes digital assets hard to be delivered and be used in the construction and maintenance periods. So in order to solve these problems and make these valuable digital assets really useful, we do the research on digital assets validation and certification and use this technology in this pilot project. And in this picture, you can see our core team leaders. Many of them are excellent professional and technical staffs. They all come from various participating units in the pilot project, including design institute, construction companies, and equipment manufacturers, etc. As I mentioned before, standard is the core element, so our pilot project is based on various standards such as the ISO 19650 series standards, ISO 16739, and other openBIM standards, and also it contains national standards. Now, let's move on to the second part, openBIM outcomes. Our pilot project has brought four main outcomes. First, we established digital assets validation and certification system. Second, we have digitized a series of standards to facilitate the detection of digital assets. Third, we developed the validation system support automatic validation of IFC format model and information. And the last one, we developed digital assets handover and application based on COBE standard. Next, before the details, please take a look at software ecosystem map. This will clearly show you what this project does. In this map, it shows three stages: construction, handover, and operation maintenance. Firstly, in construction stage, because different companies use different model creation tools in construction projects, the format of the digital assets they deliver varies. Choosing a universal format that supports conversion to store digital assets becomes particularly important. So we use IFC format as the transmission format, integrate the GIS information to build a full sync openBIM model. Secondly, we establish laboratory validation and on-site validation platform to detect model with IFC format and some relative files. After this process, based on COBE and IFC model file, these digital assets are transmitted to the for electricity O&M management system. We make the digital assets delivery from the construction stage to the O&M stage with no loss. Finally, we develop O&M digital management system with these assets. And this helps local operational personnel reduce the cost and improves the efficiency. This project adopts the IFC format with the core objective of addressing the unification of multi-platform and multi-format models. In railway engineering, participants at various stages use different software. As an open data exchange standard, IFC can break down software barriers, integrate the diverse model data, ensure consistent and traceable data throughout the entire lifecycle, and provide reliable data support for collaborative project delivery and intelligent operation and maintenance. Firstly, different format models are converted into IFC format models, and an AR/VR technology model detection platform is used to search for missing model data after conversion and add it online to maintain the integrity of the model data. The final model is then delivered to operations for application. At the same time, the project also supplements and improves information through the information platform, linking database information with the model to compensate for the data loss problems after converting to IFC model format. For the second outcome, we have digitized the standards within the system. We have organized the standards for AZ entry and developed standards management software. This software is authorized by the NCA. Digitized standard is the basic core in validation system. This can help develop automatic validation platform. Yes, that's it works. We have already extended hundreds of entries in 4 standards. These extensions perfect our standard system. And here are details of the entries we have digitized. Well, the third outcome. Here we use IFC format as transmission format, transfer other format models into IFC. After that, we have developed digital assets automatic validation platform based on IFC standard. This validation platform consists of laboratory and on-site. And on the left, it is the architecture of the entire validation platform. It consists of data storage, technical service, basic service, and gateway service. In this slide, we can see that this system can transfer different model format into IFC format and also support extract information from IFC model. Finally, it can automatically detect this information based on our programming. Self-developed IFC model parsing function. It extracts the data information to be detected from the IFC format model. After parsing data from the IFC model with our detection function, detect these data and provide the inspection report. Here's a flow chart of the validation process. There are 2 validation platforms, laboratory and on-site. Through these 2 platforms, we can detect digital models in our 4 dimensions, such as category, geometry, and so on. In this pilot project, we have validated and certified 4 digital engineering and 4 digital equipment, and these results are all approved by Chinese government. And these pictures shows the results we've achieved. And now let's move on to the handover and application. This is handover process chart. When the owner initiates a commission, certifier and validation party will help the owner to detect the certified party's digital assets. Through this process, the certified digital assets will be accepted by the owner. In this pilot project, as delivery of digital assets, there are not only digital models, but also 56 digital engineering model drawings, and over 80,000 pieces of digital asset information is included. This innovative delivery set helps engineers to get key requirements or information more efficiently and accurately than in the traditional way. So based on the certified digital assets, we have developed 4 electricity O&M management system. Many functions have been developed. Maintenance personnel can check relative digital data and management equipment through this system easily. It reduces the cost of device management and improves the efficiency. In addition, based on COBE, static and dynamic data are all relative to digital sets, making data visualization Thanks to AR and VR technology, we develop on-site validation system, and this system also help us construction and maintenance personnel to check hidden engineering easily. And finally, let me summarize the pilot project. The pilot project based on openBIM has effectively saved costs and time. These are application proofs from all parties involved in the project. And that is all my sharing. Thanks for listening.
So I want to welcome Jugal Makawana from Autodesk. He's going to speak about the strategic implementation of model delivery and IFC in Autodesk. So Jugal, if you're around, please welcome. Thank you for being here today with us, and the stage is yours.
Thank you. Thank you very much. And good morning, everyone. Let me share my screen and then get started. Just give me a second. Let me know when you see my screen.
We can see your screen. Thank you very much.
And you can hear me fine as well, right?
Yeah, perfectly fine. Thank you.
Perfect. So, good morning and thank you for having me. I am Jugal Makawana. I'm a part of Autodesk, a senior executive focused on industry transformation. And when Juan and Moses reached out, I thought this was an interesting opportunity for me to kind of get in front of you and share some of the insights on how we approach model delivery and what has Autodesk done in integration of openBIM and things. So I will be sharing few things which are kind of forward looking as well in terms of how we kind of see things going forward. And I am have a brief agenda. I have lots of slides, but I think I should be able to cover it in time. Uh, Talk about my journey, and rail is one of those domains that I'm very, very passionate about and have worked significantly and kind of share my perspective of what that strategic model delivery looks like and how open standards fit in, and also share some of the new developments in terms of the integration of openBIM within the Autodesk ecosystem and how we see openBIM evolving and then contributing the whole to the whole AI and data transition that we're going. Now, as a snapshot, I thought probably good for me to share my journey. So I am currently based in the Netherlands, where I kind of support globally on specific transformation programs from the perspective of Autodesk. But I have I have a long legacy in rail. And at one point of time, I was managing rail products as well. Spent a long time with Bentley. I was with AECOM in Singapore and moved to Singapore back in 2014 primarily to work on rail projects, to implement BIM on rail projects, and worked on high-speed rail projects connecting Singapore to Malaysia on few metro projects in Singapore as well as in Malaysia and Hong Kong. And I've been associated with Building Smart for a long time as well, to an extent that I was on the board of Building Smart for a few years, and I was also the vice chair of Building Smart International when I joined Autodesk. And when I joined Autodesk, I kind of dropped that to focus on transition. And over these years, I've had pleasure in working on some of the largest projects. So one of my first interesting BIM project was way back in 2014, where it was project in Singapore. It's a small underground metro project with three new stations, but one of the most challenging project in a way that the sheer complexity that the project had in the underground utilities and the stations, and the fact that each of the tunnel segments were different. Getting a lot of feedback.
Sorry, we had some feedback, but we've muted the source.
Perfect, perfect. No worries. Thank you. And this is so although let's say it was only a 3 kilometer project with three stations, it had close to 110 models, and the information modeling and management was being done in 5 different countries. So quite an interesting challenge. One of the largest probably was the Singapore Malaysia high speed rail project with a huge station at either side, and then a significant linear infrastructure as well. So this rail projects are very complex. Like when you're building a station, you're building a kind of a mini township in itself. And what happened in that as part of the journey was that Singapore back then had started, this was way back in 2016. So Singapore has had a BIM mandate since 2012. And then the BIM mandate kind of evolved into VDC mandate. And then the VDC mandate evolved into what they call the IDD mandate, which is integrated digital delivery. And back then, in all the rail projects that we were working on, we were looking at, okay, how do we kind of maximize the what rail had to offer, or what BIM had to offer for rail. So AR, VR, as well as clash detection, BIM-based documentation, which actually was a mandate back then in Singapore, and also looking at 4D, 5D. All of that was hinged into having a standard CDE with model content and all of that in place. And what it helped us was, so some of the projects where they measured productivity, they said that if an all integrated digital delivery framework, which includes digital design, digital fabrication, digital construction, and digital asset management, could lead up to 20% in improvement of productivity purely from a construction standpoint. And all of these were kind of interesting pointers, which kind of then I took it into the transformation program that I was leading in Haskoning, which is a consulting firm headquartered out of the Netherlands, where we kind of said we have to make the ISO 19650 as the standard. And one of the core principles in the organization's journey was having an open BIM and IFC integrated as a core principle in the transition. That is where kind of we feel that it adds value. Back in 2014, I must confess that IFC back then 2.3 did not have the kind of support for linear infrastructure that IFC 4.3 currently has. And some of the things that I think I'm sure many of you would be living through this, what we see from a rail perspective, it is a unique discipline when compared to others, because in rail, our kind of different disciplines see things differently. Some see in geometry, some see in schematics, where drawings are still the kind of default currency in majority of the world. And that is where information modeling ends up being purely a model standpoint, not an information model that we want. And and because of that, there isn't a lot of consistency in the way how things are done. What we also see is all the major projects that I've worked on so far has had an EIR and AIR and the asset information model, but many of them were misaligned, wherein different consultants and contractors and even owners had their own perspective, which has evolved. So it has got better, but it's still not at the stage where we would want. And I think the committee that you have in this can play a key role in streamlining some of that. And model federation has also been one of the biggest issues, because it is the sheer number of disciplines that we have can become challenging. IFC is being used, but more as an exchange, not really a real interoperability per se. And what we see is that the use of IFC is kind of restricted towards some of the early stages of exchange and kept more as an archival stage and not really used as something that can be taken forward as reference going forward. Now, this kind of brings me to the question, what does a strategic implementation of model delivery look like, right? So what do we kind of see it as so from my perspective, I would see kind of a strategic model delivery has five pillars, wherein we first need to clarify what is the intent, and that is where the whole ISO 19650 is relevant to ensure that we are capturing what are the information requirements, what are the asset information requirements, as well as the organization information requirements, where the owners clearly state what is it that they need as an information to do a more data-driven decision making during design and construction and asset management. And that leads to the second point, that we need to now focus on transitioning from documents to data. Whereas all the current procurement documents that you see mostly require or mandate drawings, right? Which are again a kind of document. Even if they're mandating IFC, those are digital documents, right? Whereas we need to get more and more focused on granular data and ensure that the data is classified, is machine readable so that you can validate it, and then is also has a standardized data dictionary that goes behind it. The other pillar that I see essential is a structured federation approach for the entire rail information model, which can be as discipline based as well as needs to follow contractual structure. Because what we see is, let's say in a typical project, let's say the linear infrastructure, when it comes to track or track modeling, the track engineer would do, overhead line would be done by someone else. The same goes for contracting. So that contractual as well as discipline framework of federation needs to be brought early on in the way BIM execution is being approached. And then also look at data exchanges that needs to be done, not just incrementally but also at contractual milestones, and needs to be validated, and understand what are the information needs for the life cycle of the project. And this is what we see kind of the strategic model delivery framework or pillars. Now, how do we see it in real world? So let's say if we had to kind of imagine, or this is an example of what a typical rail project could look like if we had built all of these and embedded all these strategic pillars in our execution. And this is an example of how, let's say, Civil 3D and Revit support, let's say, IFC 4.3, which is not just a model in itself, but it also includes a lot of metadata which goes along with those digital assets, and with the whole data dictionary and things, you can start embedding additional information that you need to make it a real information model. And then because you have that information either in form of Revit or in Civil 3D, you can use that from an annotation perspective or extract it for your documentation and reporting purpose. And now that, let's say, IFC also supports a much better geolocation, it can be used to better coordinate the linear and the vertical assets, right? So the track as well as the stations and everything else, and the support for openBIM and the standards goes beyond, let's say, Revit, Civil 3D, but also ACC as well as Navisworks and things. And what we see, let's say, if you look at the typical IFC or openBIM workflow, then this is what it looks like, right? So with the openBIM workflow now, with IDS is where you define what information do you need. So this is kind of IDS is a digital version of BIM execution plan where you capture and at a granular level, and then you use, let's say, Revit or Civil 3D to create your data, which would then can be exported in IFC or whatever form you want. You can also use, let's say, Navisworks and BCF to review, and then use ACC or even Forma to deliver what you want, either as an IFC or a native format. Now, someone earlier had a question on in terms of how do you validate. So, Building Smart also has a validation service, right? So, where you can validate if the IFC has the information that you need, right? So if you say, okay, you know what, I want a rail model which has the overhead line and all the information related to that overhead line should be part of that model. So you use that validation service to able to check the IFC that you get if it has that information or not, so that you're validating it before consuming it per se. And what is also interesting is that some of it's not just what Autodesk is doing, but because of ACC being a wider platform, some of these integrations have also expanded, and other partners are also doing some of that integration. Let me just play this. This has an audio. I can kind of take a pause for a second.
OpenAEC for BSDD is a plugin for Revit and Civil 3D that allows you to connect to a BSDD. Then once applicable objects are selected, insert your desired IFC entities, attributes, properties, and property sets. This free plugin allows you to easily manage properties in the native model and set up model parameters for predictable export to IFC. It maps IFC properties and Revit parameters by automatically authoring a shared parameter file. The same workflow is also available as a plugin for Civil 3D. OpenAEC for BSDD also allows you to enforce data requirements defined in an information delivery specification file to native models. Set the import target by selecting the applicable Revit objects. Set the properties and attributes defined in the IDS before automatically creating a shared parameter file and importing.
This is one of the plugins available for ACP where you can add, let's say, create a BSDD as well as an IDS, which can then be used in validation. This is an example of how BCF has been integrated with ACC as well, where you can export BCF, which is a coordination standard, and use that within ACC to be able to bring in, let's say, so if you have information from multiple disciplines, from multiple technology sources, you can kind of bring it in BCF and use that in your. So these are some of those examples, and Autodesk in a way has been one of the founding members of Building Smart International. We are still the strategic advisors and strategic member of Building Smart International, and our support for the openBIM standards is widespread. So 2.3, 4, and even 4.3. And what is interesting is that some of the newer platforms like Forma, which was announced earlier at AU, already supports IFC and openBIM standards. And what we are working towards is to ensure that everything that you do is one is that it provides the right quality, is flexible, and is consistent, not just locally but globally. And so whether you create an IFC or share a model for, let's say, US projects or European projects, there should be a certain level of consistency, at least from a data schema standpoint, that you can kind of incorporate in there. So the tools and the technology have that framework that you need to provide with custom property sets for your kind of rail projects. Now, and there is a big team which is currently focused on developing or continuing to develop these features functionality. So some of the things that they're also investing in terms of how can we make the whole experience of import and export of IFC much more efficient and faster. So let's say compared to 2024 and 2025 and 26, there's a significant improvement in speed. They're also looking at improving the quality that, let's say, so this is, let's say, the IFC extractor, which was 2.3, but with 4.3 and the additional georeference support that it has, the newer IFC and the support in ACC is much better. So you can kind of see the difference in the way that extractor is able to deliver and the quality that you're able to do. Obviously, the speed again is much faster, and there are significant, let's say, enhancements which are being done. There's a whole presentation which was done at AU on openBIM workflows for Autodesk, which is most likely available on one of the Autodesk portals for you to see. And happy to have a deeper dive with the technical team on how some of these things exactly work. There's also significant investment in IFC from a civil 3D perspective. And as I said, you should definitely explore the validation platform that Building Smart International has to offer to check on the IFC that you're getting and the quality of it. And I think Civil 3D and Revit are likely to be one of the first platforms to be certified for IFC 4.3 and the way they handle. And as I said, some of the like Forma already exports IFC 4.3. So let's say, and imports as well. So if you're using Forma, if you want to import an existing model, you can actually bring IFC as well as Revit in there in here. And the roadmap kind of continues. So there is a lot of enhancements and developments that are likely to happen and will continue. So one of my colleague Angel Valles, who's kind of a fellow at Buildingsman International, is responsible for, let's say, implementing IFC in Revit. Is also now part of the standards committee and driving to ensure that the interoperability and integration of IFC is by design and a lot more proactive. So what you should see is you should see more features, functionalities, which allows you to do, let's say, category mapping in Revit through Excel and the data dictionary that you have, as well as be able to provide a custom property set that you have so that you can map it from your, let's say, like for on a project, let's say your overhead line would have a custom property set, your track would have a custom property set. So you can kind of start modulating and adding those custom property sets in those elements so that it doesn't become one monolithic document or stuff. So there are lots of interesting things that are happening. There's also support for Excel-based mapping that is coming, as well as country kit support. This is one of those, let's say, this has been kind of now available on all ACC project is the data exchange, which actually can help you granularize the IFC. So let's say if you get a whole monolithic IFC with all the disciplines, everything in between, but then you say, okay, you know what, I just want to create an IFC which has my tracks in it, then you should be able to do that with the data exchange and say, okay, can you extract all the tracks and package me as a separate IFC? So you can do that. In this case, let's say they're doing it for a structure or mechanical. So you can actually extract and then create subcomponents of those IFCs, which can have that dependency, and then use it in whatever technology you want to do. Bring it in Revit or Civil 3D or whatever you want to do, should be able to do it. What one of the pivots, or let's say Autodesk is now focused on, is kind of ensuring that everyone has kind of access to that granular data, and that is where the whole AEC data model is being kind of configured, where the data dictionary or BSDD is also one of those foundational pieces that offers custom Revit properties which are embedded in those AEC data model, where you should be able to assign additional properties. And with the whole, let's say, advent of large language models, you should be able to now, within ACC as well as Forge, with the Autodesk Assistant, have a conversation with your models. So whether that those models are in IFC or in Revit or Civil 3D format, you should be able to have a conversation and then also use it to check and validate, oh, does this have these properties, or what are the properties that are missing? So there are additional ways through which you can now interact with the information model, and then again export IFC. You can kind of, instead of doing it through the UI, you can just type and say, okay, you know what, can you extract this? So there are lots of possibilities that granular data brings in, and that is what brings us to, let's say, IFC 5, which is, let's say, a more granular cloud-based data exchange, which is again based on IFC 4.3, but something that is modular, that allows us to exchange data on the cloud and cloud without actually having to create an IFC. So that is something which is quite exciting, and which should be kind of would be the norm for cloud-based collaboration going forward, and for the desktop-based, whereas when an owner needs an IFC as an exchange for archiving perspective, that would still be available. And all of that kind of leads to the whole AI side, wherein once you have that granular data, you should be able to use one of these assistants to be able to query those assistants. Say, okay, can you help me analyze this track alignment? Does it comply with the, let's say, New York MTA standards, right? So you should be able to do all of that validation in here and then export and import IFC or whatever. So there's some very, very interesting functionalities that are being enabled, and granular data is at the core of it. And IFC and openBIM will play a much bigger role than what they're playing, right? So whether it's for compliance and checking and all of that. So there's some very interesting developments that are likely to kind of bring in. One of the other areas, so if you're working with point cloud, again, I know IFC doesn't support point cloud and doesn't need to support point cloud, but there are, let's say, AI and machine learning capabilities that are available in recap, which are able to now extract, let's say, rails, and also create your gauge and understand what is your cant, which can then be directly brought into the Civil 3D. And these are all, from our perspective, aspects of strategic, let's say, model delivery or information model delivery from a rail perspective. And yeah, once you have this in Civil 3D, then you can export it as an IFC for sharing it with the wider stuff. So, and there are lots of new developments and enhancements likely to come from an MCP perspective for both Civil 3D, which would help further integrating and interrogating these models with other tools and technology. So a lot of these enhanced, interesting developments are likely to be based on granular data. And if you have IFC, you can actually bring it in ACC, put it in those specifications, have a conversation with it. So understand, let's say, risk, and a lot of that thing can happen. So what the bottom line is that we are transitioning from a static file-based collaboration to granular data-based collaboration, and you should see more and more tools and technology that enable that granular database, data-driven interoperability. And it's not just interoperability from an IFC perspective, but there are other standards. So OGC as well as ODA, ISO. I'm actually speaking at DEXP, which is the data exchange in the process industry, where they're looking at integrating BIM and the process work. So it is not just IFC on its own, but the whole open BIM workflow as well as the wider like we have to connect, let's say, OGC, which is the geospatial standards with our BIM standards, so that from a rail perspective, both of them are equally important. So the GeoBIM integration is also important. And then all these organizations, whether it is, let's say, Autodesk or Nemetschek or Bentley, all of them are investing in cloud-based platforms. So we do need cloud-based collaboration and interoperability mechanisms as well. So these are lots of interesting developments. So what you should see is going forward that all of these platforms will be open, will be extensible, they become a more data-driven platform, and you should have the flexibility of using the platform so that you can unlock the whole data and the granularity of it, and be able to use AI and invest in standardization and visualization of all of that. So in future, as we kind of transition from a document to a data-driven industry, we need to start looking at how do we make it accessible, how do we make it connected and usable, and open BIM and IFC is going to be an integral part of that journey that we do. And in that journey, I also wanted to kind of highlight one more thing, wherein it is not just about what we do. So, in earlier this year, I was invited to speak at to deliver a keynote at Building Smart Finland event, where they said, what is the role of standards and standardization in the age of AI? And I was kind of trying to kind of share that all of these technologies, let's say, offer standardization. So I'm sure many of you would relate to it. Let's say if you're using a pretty heavy or older machine, you would have seen it has a different port for different purposes. So let's say internet had a different port, display had a different port, USB and all of that. But now USB-C is kind of the standard, right? So it can do everything. It can do audio, it can do video, it can connect with your display, all of that. But what we see is that in real world, the adoption is not the same. So there's a huge difference between standards and standardization. And let's say all of these standards, whether it is open BIM and IFC, are available in these technologies for you to use, but it needs a user and people at your end to start looking at newer workflows and to looking at, okay, how can we use differently? And that is where, let's say, the work that Moses and Juan and the committee is doing is quite integral in ensuring that the community, the rail community and the projects invest in standardization, because all those standards are already now enabled by these technologies. So this is just a quick shout out from my side, and thank you very much for having me. I'm happy to take any questions that you might have.
So we are going to move to the next presenter, Jose Alejandro Civera. He's going to present about openBIM models I've seen rail projects in ADIF, Spain. So, Jose, thank you very much for joining us.
Hello.
The stage is yours.
Okay.
If you can share your screen, Jose.
Yeah, sure. Yes. Give me just 1 second. Okay. Which one? This one, I think. And now I have to remove this.
By the way, while Jose starts sharing the screen, Jugal, feel free to stay around and enjoy the rest of the presentations. Jose?
Okay. I guess you can see my screen.
Yeah, we can see your screen. Thank you.
We see your
Okay.
screen. Your camera is not on.
Really? I see myself on the camera.
Yeah, we can see the camera.
Yeah.
Oh, okay.
Sorry. Okay, so thank you. Thank you, Juan. Thank you. Welcome, everybody, for this presentation. First of all, I would like to thank Building Smart USA for giving us the opportunity to present our experience in this project, which is audit of openBIM models in railway projects for ADIF. First, I will introduce myself. I'm Jose Alejandro Civera. I'm the head of the BIM office in CENER. I'm a senior civil engineer with more than 20 years experience, specialized in BIM management. Been the last 8 years focused only in BIM management and for big projects. I'm also the head of the BIM management team in CENER in Spain. And I have experience in some projects like the Line 3 Panama Metro, the Porto Metro, and El Cairo monorail in Egypt. This is the agenda that we are going to follow during the presentation, but I prefer to skip. I have several slides and I don't want to run out of time. Okay, first of all, I will introduce CENER. If you don't know us, we are a company with one purpose, which is transform the world by challenging the boundaries of technology. This purpose is aligned with our vision and our mission, which is there. But just to let you know, CENER is the largest privately owned engineering company in Spain, founded in 1956. We are more than 4,000 people around the world, and we have a backlog last year of 1,500 million euros, and 83% of our sales are outside of Spain. Okay. We have presence in 18 different countries with local offices, and we have developed projects in more than 40 different countries around the world, as you can see in this picture here. And we are organized in 4 main branches, which is aerospace, mobility, energy, and advanced facilities. I will focus on mobility, which is the company I involve, and which is the company involved with the rail projects. About CENER Mobility, we design all kinds of projects, but if we focus on the rail and transit, we have designed more than 15,000 kilometers of rail, and we have designed more than 1,700 kilometers of transit with all the different disciplines involved in the project. If we zoom in North America, CENER has presence in North America since 2008. There are more than 600 employees in the offices of Toronto, Los Angeles, and Mexico. Unfortunately, no one of the office of Los Angeles could attend today, but I will try to explain their experience as best as possible. Some reference projects in Canada and Mexico, like, for example, the Quebec City LRT and the Toronto West Extension LRT. And in Mexico, for example, we have the Maya train, with more than 1,000 kilometers of train design in a basic design stage, and also Guadalajara Metro Line 3 that was involved several years ago. And in the US, as you can see, there are plenty of references. I guess the most important, the California High-Speed Rail, where we have been involved in different packages. Also, the Maryland Purple Line extension, the Bright Line West in Las Vegas, and some other reference that you have in the presentation. Okay, if we talk about BIM implementation, well, we have been working with BIM tools since 2008, but only for modeling until we have reached 2012, where we have BIM model development in a higher level. Then we moved into BIM management in 2014. And in 2017, we start the BIM implementation with the creation of the CENER BIM office. And also in this year, we joined the Building Smart Spain chapter. We are partners on Building Smart Spain chapter, and we have several collaborations and also participate in some of the activities they have. Then we have experience with BIM data management, with system integration. And then in 2022, we were certified in the ISO 19650 as lead appointed party. In 2024, we implement ACC as our main CDE for the projects. If we can decide the CDE, it is the one that we use. And then in 2025, we recertificate our ISO 19650 certification, now as lead appointed party and appointed party. Okay, so now that you know us, I will introduce our client in this project. Our client is ADIF. ADIF is the Spanish Railway Infrastructure Manager. ADIF is the responsible of the design, construction, supervision, and maintenance of the rail network in Spain. Is one of the biggest public companies in Spain, of course, for infrastructure. They manage more than 15,000 kilometers of rail network and more than 4,000 kilometers of high-speed network. It's the second large network in the world for high speed, and now also they are developing around 2,000 kilometers more of this. ADIF has invested a lot of effort in terms of budget and in terms of time for a BIM implementation in the company. They started in 2016, and they have been developed several implementation contracts to create their BIM standard manual that I will explain you right away. But you can see here, for example, that there's some milestones in 20 and 20 they defined BIM specification for the projects. In 2022, they had the first version of the BIM standards, and in 2023, they published the CDE mandatory for all the projects in ADIF. The ADIF has been pushing forward hard to the implementation in their projects. I will leave you there some links if you want to have more information about the BIM implementation in ADIF. This is a presentation done by Javier Lozano in the latest Rail Summit 2023. I think it's quite interesting. Okay, now about the project. Okay, the project is a peer review of high-speed rail projects. The official name is in Spanish, Servicios para Supervisión Dinámica de Proyectos en ADIF Alta Velocidad en régimen de pedido abierto. This is a public tender process. What we have to do in this project is to review complete high-speed rail projects involving civil works, track, stations, depots, electrification, signaling. It depends on the size of the project. This includes technical review for all disciplines involved and also BIM review. Of course, the project have been developed by other designers, and the projects that CENER develops for ADIF are reviewed by different companies, of course. The first contract started in 2017 up to 2020, where we expected to have 36 projects, but in this first contract there was not BIM projects because the BIM implementation on ADIF started around those years. Then the second contract started in 2019, also expecting 62 projects without a BIM requirement, but then there was an addendum where they included 22 BIM projects that will be reviewed from 2022 and to 2025. And then also we get a third contract now with a BIM project in the contract as well, more than 50 BIM projects that we are now reviewing. The total budget of the contract is around 8 million euros. How did we approach the contract? Well, this peer review, we didn't have a clear schedule when the reviews will be available, so we defined different teams that will work in parallel. We have to take into account that each review will take 3, 4, 5 rounds to review until all are approved. And then this makes us difficult to organize because we need to reduce the review timing, and I will tell you later some of the points that we put in place to reduce this. Well, this is, I don't want to get into much detail, but this is a short sketch from the different steps that we need to do during the revision, but mainly, just to let you know, we receive a design project with report, drawings, specification, BOQ, a BIM execution plan, a BIM models. We have to review, and we have to provide that review report and come back to the suppliers. Not much detail there. If we move into the BIM deliverables review, as I said, part of the project is the technical review that is done by the technical team, and part of the peer review is the BIM deliverable review that is done by my team. First, we receive from the supplier the first version of the BEP, the project, and also the exchange information requirement that they have used for the development of the project. We have to take into account that ADIF is in an implementation process and their standards have been improved. So we need to have the specific version of the standard that they have used to prepare the BEP. This documentation is shared with ADIF, and ADIF shared with us in their CDE, in the ACC. We check if the documentation is ready to be reviewed. If not, we come back to the supplier. If this is ready to be reviewed, we start the process. We develop the BEP review process and prepare the report. Come back to the supplier. After 1, 2, 3 rounds, we have the BEP approved, and then after that, we can start receiving the models. I have to say that this time frame depends on the project, but could take 1 year, 2 years, 6 months, depends, since we review the BEP until we receive the models. With the models, it's similar process. We receive the models, native, IFC, all the exports, whatever is needed as per the requirement, and do the same. We compare against the BEP, not against the requirement, because the BEP has been approved, but the process is the same until we have the approval report for the model. Software that we are using Autodesk Docs, we are using Navisworks, BIM Collab, Power BI, Excel, and OpenText, which is our internal software as well. Current status, just to let you know, we have been reviewing 54 different projects from 29 different suppliers. We have done 275 reviews for different documents, expend around 1,300 hours for BEP reviews and around 1,200 hours of BIM models, and we have more than 15 different reviews in the process. Okay, now I will explain you the ADIF BIM documentation framework, which is the basis for this project. As I said, ADIF is in the BIM implementation process, and they have developed their BIM frameworks. This framework refers to a set of rules, standards, and procedures developed by ADIF to define the BIM implementation in the different projects. This framework is key for the standardization for the project, which is key to explain the process that we have implemented. And the primary goal is to enhance the collaboration, efficiency, and quality in the management of the ADIF infrastructure projects. They have 3 main columns for the support of this framework. The first is the BIM manual for BIM implementation, then the BIM style guide, and third, the specific guidelines for BIM uses. I'm not going to go into much detail, just let you know that, for example, for the BIM manual, they have documentation, public documentation for the suppliers that take BIM terms, introduction to BIM, BIM in project phases, in construction phase. If we move to the style guide, they have a guide for the BIM execution plan. They have template for sure. They have template for the master information delivery plan, for quality control, for all the attribute matrix for all the P sets that are required. Also, they have guidance for the BIM execution plan audit and the template for the audit. We'll explain you more in detail later. Also guides for the data generation, for the IFC generation from different software, also for coding. There are a lot of guides for the CDE, for the uses, the BIM roles, the guide for all the folder structure that must be used in the project, also for the file coding system, etc. Everything is standardized, the standard. And the third column was the specific guidelines. They have developed specific guidelines for all the BIM uses requested in the projects, for documentation, collaboration, 4D, 5D, sustainability, etc. They have a lot of documentation that can be used by the supplier. Okay, now explaining more in detail the review process for the BEP, for example. The supplier elaborates the BEP and the different annexes that are requested by ADIF, and this documentation is reviewed against the ADIF BIM frameworks. This BP has the main document and different annexes. They have mandatory to have a master information delivery plan. They have a BIM project manual, attribute matrix, model mockup, which is a mockup of the models that they have to provide during the BP development to trust that the supplier knows how to coordinate different models from different software in one only federated model. Also, they have object classification, file naming convention, etc. All these annexes are mandatory by ADIF and are part of our review. The review takes into account 123 items to check, some general comments and some specific ones are organized in different groups that you can see there. For example, BP structure, BIM strategy, quality control, etc. I don't want to spend much time on this. And what we need to do is to evaluate each one of the items on rating, saying if this is a pass, no objection, if there are comments that should be attended, if it is failed, which means that this point is not aligned with the requirements, or if this is not applicable. Okay. The BP review process, as per our experience, we have limited room for automation. What we are trying to do is to compile typical comments or typical non-conformity. So we will have a first version of the report already with the responses that we will have. We try to share, of course, our previous audit reports with all the teams so they could take into account. And also we are having some action with ADIF to try to improve some of the checks that we have to take into account. Okay. If we move into a model review process, which I think is the most interesting point, the supplier needs to elaborate the BIM model according to the previous BP approved, the previous stage. And in the review, we need to check 65 items, 21 stated as critical and 44 stated as non-critical. The checks are grouped in different subgroups. One for general requirements, other information on files, geometrical checks, information on objects, interoperability with IFC, 2D drawings, 3D coordination, 4D simulation, and 5D bill of quantities. Each group, there is a maximum score of each group that the supplier need to get, but this is now under review because this score is going to be removed at the end. All the points, all the checkpoints need to be with a positive evaluation. What we do is go in through the audit checklist to check all the points there and provide a rate if this is approved, if not, or it's not applicable. And again, this is under review right now. Okay, and what is the process that we have used to review the BIM models? Okay, we have done 4 different scenarios that has been evolving during the development of the project. First, we're starting by manual review process. I mean, there is no specific, we didn't use specific software for auditing. There was no automation. We only check typical comments, and we make a sampling check, taking the most representative elements. And the deliverable that we have at this point was only the Excel file that I explained before. I haven't explained, but the models that we need to review are native models and IFC models, and especially IFC models because ADIF request is mandatory for them that all the models should be in IFC 4x3, or also they allow to have 2x3 in case of some limitation of the software. Then the next step that we took was to start using Navisworks Manage as the tool to make the review. We prepare with a selection inspector in Navisworks Manage, where we define all the different parameters that ADIF request in their frameworks. And with that, we extracted all the data from the federated model. This federated model is done using the IFC models of the different disciplines. And then we export all the selection and we get all the object information into an Excel file, And with that Excel file, we could check more in detail the different objects that has the parameter, is the parameter are correct or not. And also, of course, we use Navisworks to detect classes and duplicates elements, which are part of the review. This process, of course, is more accurate. The Navisworks configuration is shared between the different teams, and the class analysis, of course, is easy to be obtained. In this stage, the deliverables were Excel file report and some indication about a specific object. Okay, we give the supplier some indicating, instead of saying there are elements without the parameters, we started to say, okay, the elements of this model are round, or they don't have the parameters, or things like that. The third step was using BIM Collab Zoom. When we start the project, when we were around, I don't know, six months of the project, things like that, we had an internal discussion in the team to try to organize and automate as much as possible this process, because we knew that we will have a lot of projects to review. Then we analyze each one of the checkpoints of the audit list, and we define which one could be easily automated and which one not. We conclude that 26 of the 65 items could be automated. 10 of them are critical. The checklist critical or critical at the end only affects to the rate that the supplier is getting during the review, but finally all the points need to be approved, so in the end it doesn't matter really. But we started to define different checks that will be automated. For example, if we can check if the files are in the correct software as per the BP, if the object has the correct naming convention, if the object has the appropriate Railway Innovation Hub, which is the classification dictated by ADIF, which is classification of the railway projects. Also, if the objects contain the P-sets, if the P-sets are correct, etc. And there were some points that has the duplicated object and visual interference that we already had in Navisworks. We are doing also in BIM Collab. And the way that we are doing that is that we have predefined list in BIM Collab Nexus that cover one or more aspect of this model audit template. These are shared with all the teams in the BIM Collab Cloud, and we have them some. There are some examples here. We have some lists ready to be run on the federated model to get, for example, all the parameters, general parameters that are required by ADIF. We have all the different elements with all on each column, the value for each one of the parameter. The same with the coordinate system, for example, for the different files, for 3D coordination as well, for 4D, to check if all the elements has the 4D parameters to be used during the construction simulation, as well for the 5D. And also ADIF instruct to have all the objects needs to have a unique identifier inside the project. So we check that all the objects has an unique ID. The object naming, ADIF instruct that all the objects needs to have the discipline, dash, the object, things like that. And also we check that the Rail Innovation Hub classification is properly assigned. The Rail Innovation Hub dictates the classification number, the IFC type, and the IFC description. This is checked with this process. And also the IFC format that has been used to check that is aligned with the BEP. What we do is all those lists are exported into Excel, and we have already some templates in Excel to upload this data. So we could check easily, for example, this one, if we have received all the models that are stated in the MIDP and in the BEP, and also check that the codification is exactly the same. We have one template to get all the data are aligned with the Rail Innovation Hub, and we can automatically define which object doesn't have the proper IFC description or the IFC type that should be implemented. The same for the naming convention. We automatically detect if the objects are properly named or not. If we have duplicated unique IDs for the object, these unique IDs are assigned manually by the supplier. We are not, ADIF is not using the unique ID of the IFC object. So we need to check that this is properly assigned. And with this process, we have a more accurate audit process. We have standardized with all the team, as we have everything shared in the cloud space in BIM Collab. We have more checks automated during this process, and what we deliver here to the supplier is the Excel file of report, of course, and also auxiliary info in Excel format for all the different checks that has been automated. This helps the revision process of the supplier and speed the review process as well. With this, we are checking all the objects in the model, not sampling. We are checking all the information. We need to export the information to Excel format, of course. And I have to say that with this process, we have some issues when we are reviewing IFC 4x3 property sets and coordinates. In some cases, BIM Collab Zoom is not reading properly the files, but it's something that we are managing with them. And also we're having some issues with large models with a lot of elements. For example, a track model with thousands of sleepers. We are getting some issues when exporting that information into Excel file because in some cases the software is not fully compatible with so many elements. Okay, and the last step that we have done in the process is model auditing with Power BI. What we are doing with this, as I said, when we have the BIM Collab review process, we have a cloud space for each one of the projects where we upload all the IFC files for the project to be reviewed. This helps us to connect that data directly from BIM Collab Nexus into Power BI. So we don't need to export the information into an Excel format. And what we do is directly get the information from the Navis Nexus space. And the only thing that we need to have to make this check is the Rail Innovation Hub codes in an Excel format, the Excel table with the codes of naming convention, and the list of the submitted files. With that, what we are getting is a dashboard with, for example, the model organization to know that all the federated model is aligned with the federated, with all the files stated in the BP, for example. We are getting directly the object naming convention checks, where we have also, we can filter to identify which discipline or which model has pending classification elements. The same with the Rail Innovation Hub. This is automatically now. We don't need to export into an Excel, and we are getting how many objects are properly assigned, but which not. The same, we are getting the same by files if needed. And this information is an additional step to the review process, more accurate, more simple. We don't need to make exports. Power BI share in a SharePoint, internal SharePoint, so we can publish to the suppliers so they could check the information directly there. Now we are getting additional checks automated compared with the previous process, and the deliverables are, of course, the Excel file, which is the contractual deliverable, auxiliary info from check the model, and the access to the Power BI. This process, I have to say that there are some issues with the Power BI dashboard sharing with external users, but it's something that has been solved. And also, this has been used for internal audit for senior projects, because at the end, it's the same process that we need to do internally for the projects that we develop for ADIF. Okay, and conclusions. Well, this process works because ADIF has a really good standardization. If we didn't have this standardization, all the automation didn't work properly. Also, because this audit is based on the audit of IFC files, okay? Native files we need to check as well, but we receive native files for a lot of different software, with Revit, Civil 3D, InfraWorks, we also for Bentley, also for Istram, for specific software, so we cannot have a standardized process for all the different software that native for software that we receive. And about pros and cons, the standardization was key to adapt the process review schedule, because we reduce a lot the time spent for each one of the reviews, and also allow us to have different teams in different locations that could do the review process. And the cons, we have limitation. We're working with heavy models or models with lots of elements. We had limitation of the number of checks that can be automated right now. And we have different results depending of the IFC viewer that the supplier is using, and the BIM collab. It needs to be agreed that the BIM collab is the IFC viewer for the review, because we get different results depending of this software. And also, as I said, there was some issue with the IFC 4x3 implementation in some of the software, at least a few months ago, and we're expecting that the software supplier will solve shortly. As I said, there is a clear decrease of the hours needed for the review of each project. You can see here a downward trend for the review of the models. This is something that we have learned, of course, that we can use in some other projects. No, it's always worth to plan, organize, standardize, and automate. We don't want to be always producing. We need to take a breath and define properly the strategy. We have managed to create a really good, accurate review process, and ADIF is really happy with the process that we have implemented. And for the future improvement, we want to try to automate more checks, improving the Power BI process. Also explore the use of AI in the review of the BP documents, because now I think that the AI is quite powerful to this work. Investigate the implementation of the information delivery specification, but this should be aligned with ADIF, because we think that ADIF should be the one to develop these IDS files. And also check the applicability of the IFC validation service from Building Smart that you have available there. If you want to check this, this web page allows you to upload your IFC files to check if the IFC schema is aligned with the Building Smart standard. And finally, if you want to know more, this is an extract from the presentation that we did in the Autodesk Rail Summit 2024, together with my colleague Nuria Martinez, that today she couldn't attend, but you will have the link there if you want to have more information. And that's all from my side. Thank you very much for your time. And if you have any question, feel free.
Okay, yeah, good afternoon, everybody. Thanks for joining. I'm honored to be here, and we'll go ahead and get right into it. So today I'm going to talk to you about Michael Baker's work with CSX on their Alexandria Fourth Track project.
Thomas, are you able to turn on your camera for us?
Oh, yes, absolutely.
There you are. Thank you very much.
Apologies. Yeah, so today we are going to talk about CSX Alexandria Fourth Track project between AFRO and then additionally between Franconia and Lorton. So this is a total of about 12 miles of corridor in Alexandria, Virginia, where we have used Synchro 4D and some BIM approach and software to phase properly the project in these 2 6-mile sections. And with that, we'll jump right in. For those of you who don't know, my name is Thomas Kinney. I'm with Michael Baker International. Michael Baker is a civil consultant firm based out of Pittsburgh. We have several offices all across the country and about 5,000 employees total, mostly specializing in infrastructure, bridge structure, and land development. So this project in particular, just a real quick introduction. Transforming Rail in Virginia is a generational effort to expand passenger rail service in Virginia. CSX is working with the Virginia Passenger Rail Association and the Virginia Rail Express to make passenger rail more accessible for folks in Virginia for the purpose of commuting and intercity travel. AF to RO is 6 miles of 4th track on the old Richmond, Fredericksburg, and Potomac subdivision in Arlington County and Alexandria. And again, I will also be covering Franconia to Lorton, which is close to this. And CSX is leading design and construction efforts in collaboration with DPRA and VRE, as I had mentioned. So our construction activities to be coordinated include adding a 4th track between AF and RO interlocking, and then once again adding 3rd and 4th tracks between Franconia and Lorton as well. Upgrading AF, Slater's Lane, and RO interlockings along this corridor. Then replacing a pair of, here's my screen, it's frozen.
It's not moving.
It is not moving.
Try to share again. Stop sharing and share again. Oh, good. Yeah, try again. Just one more time to reach a time. There we go.
So anyway, continuing on, part of the construction activities include replacing rail bridges over King Street, Commonwealth Avenue, 2 major arteries in Virginia, or in Alexandria, and then renovating Alexandria Station, and then reconstructing the station in Crystal City, putting in an entirely new Crystal City station. Challenges that CSX and its partners had to consider included the fact that ideally 2 tracks would always remain in service to maximize the amount of traffic during construction. So while we have the other 2 tracks under construction or otherwise out of service, we wanted to keep at least 2 in service at all times, which proved difficult because part of putting in the new 4th track required us to shift around the other 3. We also wanted to keep 2 platform edges available at the stations whenever possible. Again, just to maximize passenger traffic when possible. And the track and the civil work were going to happen concurrently. And so we had to safely and efficiently replace the bridges while also keeping tracks online, keeping road traffic underneath the bridges flowing as smoothly as possible, So we wanted to minimize those bridge construction times. Then, once again, all these challenges were compounded by the fact that the proposed alignments overlapped with the existing alignments, which meant that construction of new rail would require the shifting of old rail or the rail. So a multidisciplinary team was formed with the following goals: produce a construction sequence for the AF to RO corridor and also Franconia to Lorden, use existing information technology and leverage 4D building information modeling software. For the case of these projects, that software would be Synchro 4D. Building information modeling was to be used to provide real-time visualization and workshopping for this project. Unfortunately for AF to RO, several external time factors included full incorporation of 4D BIM in the project, but the system was still in development. And as I will talk about later in the presentation, we're in the process of fully realizing this for the Franconia to Lorden stretch. And so the workshopping fell into three facets as we were going through the development of the project. We had finished design files from a different firm that we were using to construct the phasing plan. And so we did that, the bulk of our workshopping in almost a proto 4D modeling software. Well, it was OpenRail Designer, but we used saved views and a task tracker in combination to create 4D or proto 4D modeling. And then from there, in order to get the signals group buy-in, we created these interactive dispatcher diagrams using Python programming and the Streamlit app. This was in a browser, and it was readily available for anyone to provide the link to just access and use as they saw fit. Then after that, our construction services team came together, and our construction services team came together and put together a schedule kind of showing the best way to chart this path forward after we had workshopped it out with CSX and VPRA and VRE. So first, just talking about developing the construction schedule. We had major construction phases, task trackers, and OpenRail saved views. And I'll show you kind of how these OpenRail saved views work in just a minute as a Proto 4D software. Work breakdown structure and activities. So we broke down the work, broke it up into, what construction forces we would need and how much time, what construction forces we had and how much time they would need to perform the construction activities, and then just sequencing the activities so that we could make them happen in a safe and effective way. So after we calculated the durations of the different activities, we identified the longest path of everything that needed to be done. And that went into the schedule. We integrated stakeholder input as we were juggling 3 different firms who all wanted to do different things over the course of this project. And so we put all of those activities into kind of one plan and make sure that we could execute everything as we needed to. And, we identified where the different activities would conflict. When you're replacing the station and platforms, certain tracks have to be out of service so you can safely put in that platform. Certain tracks have to be out of service so you can install a pedestrian tunnel underneath the tracks, so on and so forth. And again, all of that would just go into the same plans. And before we got into the 4D modeling, everything culminated into this phasing diagram that, again, just showed all the work in a given phase, which tracks were online, which tracks were offline, which tracks were under construction, and all the other construction activities that had to go into it as well. The key milestones, especially. And again, just going back to the schedule and refining it. This was a Primavera P6, and we tied in everything that we needed to and found that critical path, and we maintained that critical path to the best of our ability. Which takes us into kind of that first approach of the software, so the Bentley Save Views and Task Tracker spreadsheets. So Bentley Save Views are very convenient. You'll see on your screen here kind of what we saw on the when we had the phasing open. So we had a grand file that had all of the different phases in it. And with Bentley Save Views, we could choose what phases were active in the drawing at the time, and even what lines were active within that phase, what levels. And so we could very easily click on one of these. We created these saved views, and we could set them however we wanted to. Then all you had to do was click on one of these, click on the screen, and it would instantly open up to that saved view in our kind of proto 4D approach. And that would allow you to show how either one spot changes over time, or you could walk down the line in one phase and just see all of the major construction activities. I will demonstrate both ways here now. So walking along the line, we're starting here at station 125. You'll see we just have that first track down at the bottom of the screen, offline. 3 tracks above are online. Walk down to station 230. So walk down a couple thousand feet, and that track on the bottom is under construction. The 2 tracks in the middle are online, and that track up top is receiving some shifting work, as well as a new maintenance way spur. Keep going down, you see some track being removed, some track being shifted, some track being built. The 2 tracks in the middle are still online. Then onward to station 295, same thing. This is where a lot of the existing right-of-way overlaps with the proposed right-of-way. So we had to be very careful about phasing all of this to make sure that we could get 2 tracks online at the same time. Finally, 315. This is right before Long Bridge and RO interlocking. Again, just more construction, more removal, and keeping those 2 tracks online. I can also show you how the tracks change over time at one spot. So this is that complicated area where the existing and the proposed overlap quite a bit. This is phase 1. Phase 2, you see we have some of the stuff shifted, some of it's still being shifted, and some tracks still offline. Phase 3, we're getting into some more intensive shifting there, but because of efforts in phases 1 and 2, we're still able to keep those top 2 tracks online. Phase 4, again, shifting in the middle, but now we have 3 tracks online, which is even better. And phase 5, and after that, all tracks will be online. In our spreadsheet task tracker, each phase was put into each task was put into the spreadsheet, and then each phase was a tab. As we went through the phases, you would see green, that activity is being performed. That phase, red was a conflict that we had flagged, so we might have to do some minor changes to the actual track plan to accommodate those. And then yellow was something where a temporary outage was required on an active track. Going through the phases, as we would perform more activities, they would become blacked out, and that just made sure that we got every activity we needed to for the sake of the project. Approach number 2 was the Streamlit Python dispatching diagrams. This was to enable buy-in from CSX's signals department. It was an app on a web browser, and as soon as you could click through each phase, see which tracks were online and which tracks were off in a given phase. This was done in Python, and you could just click through quickly, and that would just give signals the information they needed to phase their signal expansions or, which tracks needed to be flagged as offline for that given phase. Through, you can see how it kind of expands, which tracks are on, which tracks are off as we modify them. Here we go. Approach number 3 was the scheduling diagrams. Prior to actual 4D BIM modeling, this is what we did. Final product manifested as a scheduling plan with relevant phasing information and durations. Lots of ink spill just kind of show the different important key construction activities. And you can see the whole corridor here. You can see which tracks were on, which tracks were off, which tracks were under construction. And at the same time, we have that dispatcher's diagram, once again, just for the benefit of the signals department. Durations for all the external construction projects were included as the information became available. Again, that was just very closely tied to our schedule. We worked very closely with construction services to make sure that came together nice and schedule grand charts. We integrated the schedule and we had each individual schedule. We had the work breakdown structure, which we logically tied into every task that we had. And we had those critical path and interfacing milestones where we could see where different activities conflicted. And that allowed us to establish baseline and maintain with regular updates. And that was all integrated into Primavera P6, which is very relevant to what we'll talk about with the actual 4D BIM modeling. Synchro 4D Pro allows us to import P6 schedules directly into it, allowing us to kind of have everything under one platform, under one roof. Yeah, and then more of the Gantt chart, scheduling. Facing all of these different milestones into one, grand scheduling, which allowed us to plan. And then finally, while it didn't happen for AF to RO, we had much the same approach with Franconia to Lorton, just on an accelerated scale, now that we kind of knew what we were doing. And after the extensive workshopping, construction on the 4D model can begin. This process had 3 main phases. The first one, the CAD diagrams that we had based on the existing design plans distilled into models. And then the action items and the schedule and the task trackers are linked to the components of the models in Synchro 4D. Then these action items are animated in sequence to show the change in the site over time. This was designed specifically to aid in public-facing meetings, and we'll get more into that in just a second. So for the model, the existing CAD design is converted into a 3D model. For the sake of simplicity, this initial model was 2D line work. Each distinct construction activity was broken down into a line string or a cell for ease of association. So this is where the BIM comes in. And, rather than breaking it down into, I know in a lot of structural BIM, you break down every bolt, every nut, every beam. We broke it down into more distinct sections. So, as a hobby, I do model railroading. And, I think of it like this way, where you have sections of individual track, whether it be a 9-inch straight piece or an 18-inch radius, 30-degree curve. Well, here, we just had, we need to build the track from station 25 to 35. So that activity is its own section of track in the model. Or we need to shift this track from here to here from station 18 plus 57 to 21 plus 45. So that becomes actually 2 models where there's the existing track and then the track to be shifting. Or the final location where that track is shifted to. And then all other line work and annotation was stripped from the model in the file, just so we can show those animations and those different tracks. And then in the Synchro 4D, each phase model was uploaded into the Bentley Infrastructure Cloud for use in Synchro 4D. The schedule prepared by construction services and Primavera was also imported into Synchro. And so we finally had everything kind of under one roof. And Synchro operated by associating a resource, a piece of the model, with a schedule task, assigning it an appearance profile. That appearance profile allows us to show what's happening. You know, we can, if a track's being installed, we can make it appear. If track's being removed, we can make it disappear. Track's being shifted, we do that with two different line strings. So the existing track disappears and the existing track appears at the same time to signify a shift. And it's just super handy that you can see how the project progresses over a certain phase. And we did this with each phase. So phase 1 has its own model. Phase 2 has its own model where it starts like it looks like at the end of phase 1, and it will end like it looks like at the beginning of phase 3, just for instance. And so we animated those sequences. Once the task, components, and appearance were established, the phases could be animated. Components of the construction, like I said, were just shown as put in service, taken out of service, installed, removed, shifted, or any combination of the above. This animation underneath shows shoe flies being constructed while the existing track is still in service. And you know, you'll see it turns yellow once it's all constructed. That's because the track is not cut over to the shoe flies yet. Like I mentioned before, this will be used for more public-facing meetings. You know, you and I know what a shoe fly is. Not everybody in the public does, and so this is an extremely handy way, kind of show the public. You know, we're building a second bridge just adjacent to the first bridge, and we're going to cut over tracks onto that bridge while we demolish or renovate the first one. Then the animations were, we put those into the Bentley I model to show the activities of the entire phase 1. I'll go ahead and play that animation for you just real quick, and we'll go through. So this is a new bridge. You see the bridge kind of fading in new construction, retaining walls going in. After the retaining walls are in, shoe fly tracks, and the cut over to the shoe flies while tracks are out of service. This is a much larger shoe fly where the tracks were being shifted rather than replaced. So we're shoe flying around this area. We're going to put in a large bypass bridge here that will cut over from track 3 to track 1. That required some shoe flying. Yeah, so that just kind of shows everything in sequence and in turn. And on the right, the bypass bridge is slowly fading into existence as it. So yeah, so those are the major construction activities of phase 1. We can just show that. That makes it really easy to digest for people who are not necessarily industry specialists. Yeah. So what's next? All the phases will be animated much the same way I just showed you. And we're using the 2D model that we built as essentially a storyboard just to show that progression. OpenRail Concept Designer is real nifty. It's a little out of my wheelhouse at the moment, but it's nifty, and we're exploring that to rapidly bring that 2D model to 3D without having to rebuild profiles and templates from scratch. And Synchro has another tool called Synchro Modeler, and we'll be able to parse our 3D model into the different tasks that we've discussed, and we'll even be able to do that non-destructively without destroying the original 3D model. Super convenient just to parse to allow us to do more complex animations. And, hopefully the Alexandria corridor will have a full 4D model to aid in the workshopping and development of solutions to previously unforeseen problems, which was the whole point of this exercise. If you have a construction project, you have this 4D model that shows how the project progresses over the course of construction. It is our hope that you'll be able to make decisions more quickly, so that you're not making them on site as it happens, and we'll be able to solve problems before they become problems, and everything will be able to happen a lot more smoothly in the field thanks to this 4D BIM style software. So thank you so much. Question?
So Pontus is going to present the implementation of ISC on the Sweden rail business. Is that right, Pontus?
Yeah, so yeah, absolutely. It will be a rail and road focus or an transportation focus, and you will understand
Great.
later on. So yeah.
Great.
Yeah, thank you very much for having me. And Pontus Bengtson, based in Sweden. I work at Autodesk in a team, same team. I know my colleague Jugal presented a little bit earlier, and we are in the same team in global business development. So my focus is the Nordics. So I work a lot with the industry and the industry organizations and the big our big customers and also the big owners and so on that has a massive impact on the ecosystem here. So, and I've been involved in some of these works and around standardization and so on. And that's what I'm going to present. So you see my screen?
Yeah, stage is yours.
And sounds okay. So I was just thinking of starting because Juan, he did a classic mistake that at some point this presentation was called Implementation of IFC in Switzerland, which is quite easy to do a mistake and no shadow. But I felt like, okay, so what is Sweden then? So we are in the Northern Europe, yes, you probably know, part of Scandinavia, roughly the size of California. However, we are only 10.5 million people in our quite big and long country. Government, we are a constitutional monarchy, strong democratic tradition, and I think we are known for a high transparency and quite a lot of this kind of gender equality and social welfare systems. When it comes to economy and innovation, I think a lot of you guys remember we're only 10.5 million people, but we still have a really big entrepreneurship in our veins and coming from home. So the IKEA, Volvo, Spotify, Ericsson, and H&M is all Swedish companies and brands. And then we have quite a heavily focus on sustainability leadership and pioneering green energy and so on, and climate neutral initiatives. Culture and lifestyle, well, we have a tradition of this kind of lagom, which is a really hard word to translate, which is balance. And fika, the Swedish fika, coffee breaks with pastries, that's a really important thing in our society. And work-life balance and nature and stunning landscapes, and summers are mild and the winter is coming. So we are here now starts actually snowed today in Stockholm, so long and dark. And education is free, and we are ranked among the best non-native English speakers in the world, which is, if you ever come here, it's never a problem speaking English here. Almost everybody speaks quite good English. However, that was not why I was here to speak about, but I think it's especially this kind of how we work together and that we are quite a small population is quite important. So on this journey of implementation of IFC in Sweden, I would like to go back to 2020, where I didn't work at Autodesk back then. I worked at WSP, and I was project manager for a project, an industry project that was a national strategy for standardization of digital information management within the built environment. So for Sweden, we worked with this with the whole industry, and everybody participated in this work. And What we really did here was that back then there was, I'm not sure if you recognize this, but there quite often when you start to talk about this kind of IFC, or you start to talk about structure and what is needed in the industry, quite a lot of people are saying we need more standards. We need more standards. And our view back then was that is that really the truth? Do we need more standards? Isn't that we have enough with standards, but we're actually not really implementing and using them? So this project, this was government-funded project with innovation money. We took this kind of look at, okay, what is the information flow in the normal projects, and where do we have any kind of where do we have challenges in the information flow? And what are the challenges? Do we have challenges? Is it because we are the technology is not there? Is it because we're using the technology wrong, or is it because the information is not structured? Or could it be that something is that we actually are not, there is no standard, or are we not using standards correctly? And so we went through there and we identified where the most important gaps were from a time, money, and sustainability impact. And with that, the conclusion was that actually we don't need more standards. What we need is more guidelines and specification on how to use the standards that is already out there. And in this strategy, we suggested 8 projects. And when we now say projects, I mean projects on a country level projects from what government-funded projects. And of these 8 projects, 3 of them was this kind of basic applications for ISO 19650, basic application for co-class, and delivery specification with IFC. Co-class, and we'll come to that. So these 3 projects were bundled together and was started as a project that was called BIM Guidelines. And I was in the steering committee for this work, but it was driven. And once again, we're quite good in Sweden that the industry, what you can say, everybody talks to everybody and the community is strong. So, the different contractors, engineering companies, the owners, and the software suppliers and so on, we come together and we speak together and on this kind of the common goals. What should we not actually compete against each other? This is common things that would drive the country forward. And the project goals was to establish these best practices, create user-friendly guidelines endorsed by the industry, and provide practical guidance, show users how to manage this digital information for everyday tasks, and then support the implementation, develop material to help organizations adopt structured information management. And the core components was, as you saw, ISO 19650. And then in this, there's a little bit this kind of, okay, how can we actually use that for the Swedish context? Co-class is a Swedish classification system, and that's needed. And how can that actually be implemented? And then, of course, IFC, which you all know what it is. And this was the BIM guidelines. And as it is, as you do these projects, it's always a challenge to, okay, a nice report or a nice result, but how do you actually maintenance it, and how do you actually have it implemented and pushed out to the industry? And parallel, we have had this kind of, the BIM Alliance Sweden is a community industry organization where actually the Swedish Building Smart chapter is under BIM Alliance umbrella. And under BIM Alliance, we now have in Sweden, we have this, it's called Praxi. And here is a place where we have our common instructions and how we see on things, and this kind of delivery specification and terms and so on. I just switched here. Normally it's in Swedish, but I guess your Swedish was not that great, so it was better with English. And so this is some parts of this is open for everybody that should be used all industry, and some things are behind a login where you pay. And if you pay, you can go in as a owner, you can go in and build your specifications with this kind of the standards, and you can then have if you buy then or an RFP, send out an RFP, they can then be linked to these requirements. It's really nice, and it's also really good that we have one place, one source. So then we're coming back and to that, okay, this is nice. We have agreed in the industry, this is where we should move on, this is where we are heading and so on. And then of course, we need those big owners to actually take the initiative and start to put in requirements, or else I never think anything will actually happen. A little bit as I heard in the presentation before, it needs to be coming, quite a lot of the drives comes from the end client. In this case, Trafikverket, which is the Swedish Transportation Administration, and they are, and that's why I say it's rail and it's road and everything, because we have one government authority that is handling all the roads, rails, shipping, and aviation. So they have quite a lot of public roads, quite a lot of rail track, 9,000 employees, 7.4 billion US dollars in annual budget, and they are the absolute biggest owner and also the biggest buyer of services and construction work in Sweden. So you can understand that what this big client does has a massive impact, and everybody's in a way following it. The interesting thing with Trafikverket and Sweden is that we just have a new national plan for infrastructure where it's one of the biggest ever. So it's the total one is around 120 billion US dollars for over 10 years, and more than half is going to rail, and a half of that is going to new rail investment here. So that's why the topic here with rail and so on is really important, and also for Trafikverket that a lot of new rail will be built, and they also have to maintenance a lot of rail and rebuild, and that of course means that they need to be even better than they have been before to handle all the information that they get. So coming back to what we talked about and why we're here is this kind of, so they have been, and you guys that are in Building Smart, you probably met a couple of Karin Andersson and Peter Axelsson and so on that are really in the Building Smart part, and they really wanted to, we should use the openBIM thoughts with the needs, requirements, create, secure, share. And this is Trafikverket slides. Was actually a conference yesterday, so I borrowed them from Karin and I just translated it. But it's this kind of approach, and apply open standards, use the neutral format to be a little bit vendor independent, being able to move around, and also that their supply chain can use a little bit whatever they want, which is more efficient and get more bang for the bucks. And what they are doing now is that they go in and say, okay, let's go and start to require IFC with IDS as this kind of how we control the requirements, what information should be in the IFCs. And I will not hang up because you know this stuff already. So what they have done is that from 2024, they prepared in a way. And once again, remember where I started, this kind of how we in Sweden are quite in this kind of collaboration, community thinking, and how we are used to work. So they have, during this time, they have always...
Pontus, sorry.
Yeah, go.
You could. Your voice went away for a second. You keep going, sorry.
Okay. So maybe it's I'm in a hotel room, so yeah. So they prepared 2024, developed now under 2025, And 2026 next year, they're going to start to specify requirements and then start to really full-blown put in the requirements. And then it's more of an education, follow-up, and have a new vision for 2030. And as you can see down at the bottom, communication and dialogue is key words here. And they, I must say, they are really good in communicate with the industry in different forums, under the Building Smart umbrella, in BIM Alliance, and other meetings. And yesterday we actually had a conference on this, where 100 people coming. And they are now going into this kind of the first information request, and they have some metadata, coordinate system, spatial structure, and so on. And what actually they did was that they wanted to pressure test a little bit. Where is the industry? How prepared are you? If we would start to require this really, require for real, not just we want an IFC, but really this is the information we want. It should be in this structure. These are the objects, yeah, all that kind of thing. What would happen then? So they actually had an industry challenge where they put out a really simple IDS, so actually just it was just a slab with some requirements on the coordinate system, some of the classes and so on. This should be what should be on it and information and so on. And then they just said, hey, suppliers, us and engineering companies, please, if you have, could you please test and send in IFC and your comments and your thoughts? And so they actually got 11 answers on this. And as they were, it was no competition. So they didn't present what kind of tool or whatever worked or not worked, but there was more this kind of, okay, we did this. It's a massive challenge with the coordinate system. That's a really, really nut we need to crack. So, and then there was some other smaller things, but really good. And then this kind of, I feel, pragmatic way of testing a little bit, instead of just going in and start to require without a really thought behind it, is a good way to do it when you do this kind of implementation. And that was what we had yesterday, and we have had now some meetings, and yeah, I very bouncing things back and forwards, which I think is a way to succeed. And as you can see here, once again, I'm using Trafikverket slides, and they say, so this what they now have here, they are actually based on the result from the government-funded project BIM guidelines for IFC. So once again, you can see how we as a community, as a country, are, it's very intentional, the things we are doing, which of course, if you are into some kind of change management, which this is a massive change management project. We're trying to change the whole country's way of doing work. When you really have this intentional and you really connect it to why are we doing this, these are the reasons, and this is how you should do it, and we base it on a lot of facts, and we are agreeing on it in discussions, it goes so much easier. Less harder, I would say, because it's not easy, but less harder. So if you look on what Trafikverket now will do, is this kind of, they will evaluate the feedback they got from this challenge. They will prepare a little bit more on this. We also have a very big project, Bypass Stockholm, that has been delivered, and they are now doing tests on those deliverables and actually creating some IFCs, recreating DVGs and DGNs to IFCs to go into maintenance. And that project they are doing themselves, that will also give some good inputs in how they should put in the requirements on the new projects. And of course, increased competence and digital maturity, especially they feel internally in their organization. And then develop the kind of subject areas, internal work of digital maturity. And then you can see here, structured work with IDS according to Praxis guidelines. And did you remember the homepage I showed you, where the repository for our guidelines, our country guidelines and so on, that was Praxis, that was the name. So you can now see here how one of the biggest owner are really reinforcing the work that the community had made and agreed on, and then really following it through, which of course will mean that you will have this feedback loop. So the work that was done there, of course, there needs to be changes, and that will feedback, and then the guidelines and the structure and everything in Praxi will update to new versions that then Trafikverket or other owners, municipals and cities and so on, can use. And then, of course, continue the supplier dialogue. So to end up this presentation, I would say that the key things for implementation of IFC in Sweden is that it has been very intentional. It has been this kind of national community together thing. And then where we have had a very intentional way of looking at things and involving this kind of, okay, this is one of the biggest impact that has the biggest impact on the industry. They need to be on board, and then it more or less, hopefully, it will be that everybody else will follow. So actually, that was implementation of IFC in Sweden in a nutshell. I hope that made sense. Any questions?
Great. So thank you so much for having us today. My name is Lara Chow. I'm Associate Director of CIMS, and Nico and myself have been co-leading this digital twin platform project. So let you introduce yourself.
Yeah, hi everyone. My name is Nicolás Arellano. I am an architect, PhD candidate at Carleton University. And I have been at CIMS for almost 8 years and co-leading with Lara this project that the project itself has maybe 3 or 4 years, but it's following like maybe 15 years of research in this area. So Lara is going to explain that. Yeah, thanks a lot, Building Smart USA, for inviting us. It's a great honor.
So for those of you who don't know who we are, we're the Carleton Immersive Media Studio, CIMS, and we're a research center affiliated with the School of Architecture and Urbanism here at Carleton University. Currently, we have about 40 students working with us, and that ranges from part-time to full-time researchers, and we're a very multidisciplinary team. So we have people coming from architecture, engineering, computer-human interaction, public history, and even information technology. So we have 5 streams of research. The first stream of research is digitization, where we translate the physical world around us into XYZ coordinates using laser scanning and photogrammetry. We then take that resulting point cloud data and other sources to develop building information models. We're particularly well known for heritage building information models. Next, we have digitally assisted fabrication. Here we use digital technology to augment traditional workflows using robotic and CNC milling. We have 2 robots at the School of Architecture. Digitally assisted storytelling is where we create engaging public experiences using these digital assets such as online tours, virtual reality, augmented reality experiences. And our 5th stream of research is something that we've been working towards, as Nico said, for the past 15 years, starting with kind of large-scale urban modeling that then moved into dynamic representations of the built environment into digital twin. So the team that's working on our digital twin platform is about 8 students, mostly undergraduate developers led by Nico, Steve, and myself. And the majority of the platform that you'll see here today was developed by this team over 24 months, but it builds on a foundational research project called Imagining Canada's Digital Twin, where we were awarded a New Frontiers in Research Exploration grant, and is really about the idea of what would it take to develop a digital twin of Canada. So before we jump into the platform itself, I'll talk a little bit about how we define what a digital twin is to us. So there's many definitions of digital twins, and ours is based on one by the Digital Twin Institute. So its director, Michael Grieve, states there's 3 components to digital twin. You have the physical thing in space, and then you have the virtual version of that product in a virtual space, and then you have a feedback loop going between the 2. So this is fairly straightforward when you start to think about maybe a digital twin of, let's say, a jet engine. But once you start to think about digital twin of Canada, which is quite large, it gets to be a lot more complicated. So for CDT, we're trying to capture the physical environment. So here you see the physical Canada, and that includes the physical, the people, the built environment, the natural environment. But we're also trying to capture some of the non-physical networks and processes. So we have the history and culture of Canada, government jurisdictions, climate, environmental systems. And then you have a digital transformation that occurs that basically translates all of that into data. And for us, there's two kinds of data. We have open data, which is public data. This is data that you can find through different municipal, federal, provincial portals, and anyone can see them currently, but no one really brings them together into one system where you can start to layer it. So we have that public open data, but then we also have data that we're calling proprietary organizational data. So this is the data that your organization or you as a user brings into the platform, and only you can see that, or the people within your organization. And this is all accessed behind a secure credential system. That information then all gets translated into the digital twin platform, which is going to be stewarded by a not-for-profit. Our mission, the not-for-profit's mission, is to democratize digital twin technologies. And why do we want to do that? So our work still happens in fragmented data silos where BIM, GIS, and operational data all exist in isolation, while proprietary lock-in traps us in expensive, inflexible software ecosystems. Poor BIM and GIS integration and technical knowledge barriers further exclude non-technical stakeholders. Think about CEOs, people managing the buildings, from accessing this information and making informed decisions about the built environment. So our response to this is a web-based open source data visualization platform that federates data, including BIM, GIS, open data, and multimedia. It's based on open and international standards, and it will be accessible and community-driven, governed, and maintained by a not-for-profit. Sorry, just going back here. We're going to kind of jump into each of these points in the next few slides. But first, let's start with why openness matters. So at its core, platform is about building a foundation for innovation. Most teams spend about 60 to 70% of their time creating the base for digital twin solutions. So what we want to do is provide that base ready for researchers, other organizations, and users worldwide to then build on. And then we're going to do this through plugins and extensions that each user organization can customize to the platform to their unique needs, while the core of the platform will always remain open source. So open source means transparency that you can trust. Anyone can see exactly what our software does, verify its claims, and use it with confidence. Our mission is about advancing the industry, not about maximizing profit. So this is more than just a software. It's a platform for shared innovation, for collaboration, and growth across the digital twin and built environment ecosystem.
Yeah, so as Lara was mentioning, something that we try to do with this platform is federate like different data sources. So one that is very important for our research is federating BIM and GIS that with the technology that we have been using in these 15 years of experience with large-scale BIM projects is that sometimes it's hard to integrate. So federated means that, means putting the eye of BIM and the eye of GIS as kind of like as the core, and then mixing that and federate it with all other data sets. So for example, in Canada, Canada has a pretty good reputation of like open data galleries. So you go to the federal government, for example, and you have Natural Resources Canada with like thousands or hundreds of thousands of layers of open data that you can in their portals. Sorry? Sorry, there was some voice there. So Natural Resources Canada, so for example, you go to their portal and you can access these layers, see them in a map, and then you go to Stats Canada and you can do the same. And then you go to, for example, to all of these provincial open data galleries and municipal, but it's hard to go to a viewer, a map where you can start federating all of these different. So what Lara was mentioning, these silo data sets that we have identified, we're trying to connect them, not storing anything, not verifying or creating them, but try to make the access for the users as easy as possible. So we integrate this standardized API. There are a couple of open data management in Canada that we are integrating the platform. And with that, you can also bring your proprietary data and see everything into the same viewer. The other thing that is very important is that you have the technology that is open, you have all of this open data, but that's not going to solve the issues that Laura was mentioning. We need the people. So there are different organizations, both in Canada and international, that are pushing towards this direction. So we're trying with this platform to make this connection so we can have like a hub for different groups to basically start using this as a foundation for this. So as Laura was mentioning, many of these groups have to spend like a lot of time and energy building the foundation, and we're trying to put that for free so they can start higher, and we can also benefit from all of these different groups research that is far from our area of research. So you can see many groups here: Building Smart International, Building Smart Canada, groups, provincial groups, Digital Twin Consortium, the OGC, etc., and how we can provide this to bring people together. And in order to do this, in order to federate data and in order to connect different peoples and organizations, open standards is key. So we are trying to follow very rigorously well-established international and national open standards. So for example, we have, of course, all of the Building Smart International openBIM standards. We're going to show a demo later that shows all of that integration. So IDS, BCF, the Building Smart Data Dictionary, IFC, but also there is a roadmap that the OGC and BSI have that try to connect all of these open standards. So you can find things in the CTGML, Land Infra, WMS, etc., and how we can connect this standard in order to make the best BIM GIS integration. I know that there are people here in this call that will have some technical knowledge about the open standard platform that we're using. So I'm going to spend a few minutes there showing this. But something important about this diagram, other than the technology itself, are two things. One, it's created like 100% based on open source, free and open source packages. So that gives us a lot of leverage and like flexibility, and also allow us to scale pretty flexibly, and also allow us to, on top of that, generate something that we can also share with the public eventually. So that's something that I'm going to mention later, how this is going to become another open source library that people can start using, as Laura was saying, to democratize the digital twin technology. The other aspect in this diagram is that data sovereignty is very important for us here in Canada. So we are working on having everything created locally and also served on Canadian-based cloud infrastructure. So we're working with full host, and we're trying to keep things local, and then be able to export this knowledge and infrastructure from Canada to the world. So yeah, let me show you what is this diagram showing. So at the user layer, people use this platform without having to install any software. You just open your internet browser, your preferred internet browser, on your phone, on your tablet, on your laptop, and you can access the platform directly there without having to install any software. Then in the front end layer, we have been using different libraries. So the main one for the GIS is MapLibre, and we also use their vector PostGIS vector tile system that is called Marlin. Then we also have different tools for analyzing the GIS, TURF, etc. And then for the 3D graphics, 3JS is a popular WebGL library that we use in order to make the best three-dimensional visualization and interaction. On top of that, there is a library that started in 2021 that is called IFC.js. That is a good IFC parser for the browser. Now they are called that Open Company, and the way that they process IFCs specifically for the browser, it's amazing, and we have not seen something like that. So we're going to show in the demo how 500 megabytes models load in a few seconds. So yeah, that's that. For point clouds, we are using Poetry. That both of these libraries are also based on Three.js, and then we use like PostgreSQL and other object storage that we are integrating as the backend. And in order to organize this, we are establishing as a non-for-profit. So we are about to establish that. And the idea of having this group is to promote openness, innovation, and long-term public benefit, to maintain the services that we have been mentioning, including the repository, the servers, authentication, security, etc. Also to manage data governance and sovereignty and security, including standards, protocols, and frameworks, and also to continue the optimization of the library, so augmenting the technology. Every time that there is an enhancement of any of the technology that we are using, we go ahead, we optimize it to make the best user experience. And also debugging, versioning control, providing like a comprehensive documentation both for users and for developers. And we are proposing 2 deployment options for organizations that have like more complex or more developed IT infrastructure. We allow this organization to self-host, so that means you can use the free and open source code, no cost at all. Documentation will be provided like periodically, and you will have also the community support. So that's an important part of our open source library, that we're building this community. You have full control over your data and infrastructure, and you can customize some aspect as you need. And also you can work on plugins and extensions that fit better your own workflows. Then we have CDT hosted. So basically it's kind of like a software as a service model, where we're going to provide like a platform with a free tier for people, but also organizations can have their own instance. Organization with limited IT resources can hire us to basically host the platform for them. So this means that it's going to be easier for them. They don't have to deal with all of that. We're also going to provide like more robust documentation, support, periodic automatic updates, maintenance, and everything, as I was saying, is hosted in our Canadian host data cloud server. This will generate revenue for our group and for the project to create this sustainable project.
All right, so let's demo the platform. So starting with their secure login, authentication system assigns role-based credentials with differentiated permissions based on your organizational requirements. So each organization, as we mentioned, has their own instance. So for example, Carleton University would have their own instance, and then users within Carleton University would be able to see the data within that. If you look at our left-hand toolbar, it provides intuitive access to our 3D viewers, which include a map viewer, a BIM viewer, and a point cloud viewer, as well as databases for sites, buildings, and files. And we recently also introduced an infrastructure database to manage your horizontal and subterranean infrastructure. So the toolbar also houses integrated tools. So this includes the National Research Council's openBIM LCA plugin, which uses IFC-based workflows for carbon benchmarking and automated model verification throughout a building's lifecycle. So this integration is essentially to demonstrate how our digital twin platform can create this unified, open standard-based ecosystem of analysis tools. So we'll provide the base, and then experts will come and create tools that then can do analysis on top of the platform. So let's explore our site database. So here, for example, Carleton University, you can see all of its associated buildings and any attached files. Once we jump into our buildings database, you can filter and query the data. So this is all based on standardized properties. So for example, here we're searching by building type and year of construction, and then you can filter down your database. Now jumping into a specific building, we have these data tabs on the left, and this is all standardized using the Building Smart Data Dictionary to develop these properties, ensuring alignment with open standards. So all this information is editable like a form, but we're also researching how to pull that information directly from the IFC and the GIS data into those into the data tabs. So for example, you can also get information from operational sensors as well for energy data. Now we're in the attached files tab. So here you can see all of the files attached to this one specific building. You can essentially attach any file type, but you can also preview them as well. So you can attach reports, multimedia, things like that. Now let me demonstrate what we consider our most significant technical achievement, which is kind of seamless BIM GIS integration. So here we've modeled all 45 buildings on campus at Carleton University. And we've loaded them all into the platform. And here you'll see as we add them, they load within about sub 2-second performance. And some of these models are over 500 megabytes. At Carleton University, we also have a very extensive tunnel network connecting all of our buildings. So we're going to add in some GIS information showing the tunnel network. And this can show you how you have building scale and infrastructure scale information coexisting within an integrated environment. Here it's now opening up the BIM viewer for the tunnels. So you can also isolate the BIM and bring it into the viewer. And Nico will also show some tools that we have when we demo the BIM specific tools. We also are able to add images, comments, models, videos, any type of media really to the map viewer as well for enhanced collaboration. So here we're just adding a couple images of the quad. Now zooming out to Ottawa, I'm going to demonstrate our Open Data Federation capabilities. So the platform automatically retrieves open government data. And here we're going to add Ottawa neighborhoods, transit stops, as well as national airport locations. And this integration happens through standardized APIs, so there's no data manipulation required. We currently federate over 60 sources coming from Natural Resources Canada, Statistics Canada, as well as dozens of municipal open data portals. And this makes previously inaccessible data sets easy to layer and visualize alongside your own building information. So this dynamic visualization control that we're showing here, called the Applied Layers toolbar, allows users to adjust color scales and graphic quality for enhanced analysis. And this transforms fragmented government data into actionable intelligence for asset managers, supporting data-driven decisions for all users. The data, you can also click on each one of the data points, whether that's point data, polygonal data, and you can see all the metadata that's associated with it.
And so going back to the BIM viewer, that is probably something that people are going to resonate because of the openBIM standards. So here we go to one of those buildings that Lara was showing before. They are not abstracted versions or shells, it's the entire IFC. So like many gigabytes of IFCs that live in this campus. So you can go, you can see everything inside, and they load like as really fast compared with like how they take time to load in some proprietary software that we use. Then you can see, like, of course, you can generate floor plans, you can see all of the files attached, and you can see the entire IFC hierarchy or IFC tree with all of the elements that had been modeled on authoring. You can click at them on this sidebar, or you can click at them in the 3D viewer and retrieve all of the metadata, which is the most important part of the BIM, of course. So you have like the identity data, dimension, constraints, facing information, property sets created in authoring, and all of that you can retrieve within the BIM viewer. You can also add other types of multimedia. For example, CAD is still really important for our industry. And you can use that as a reference for your BIM, for example, in the same scene. You can add 3D models, many types of 3D models, GLTF, FBX, Collara, you name it, and you can add them there. We have this feature that allow you to place the model, rotate, scale, and adding that into your own workflows. We also have point cloud integration. So for example, this building here that we scan, 3D scan, and then turn from point cloud to BIM, you can see it on the BIM viewer. So this is also using Three.js, and take you back to the BIM viewer. You can start exploring the BIM, cutting a clipping plane to go inside, identifying that this, for example, this object has been misplaced. So I measure and I add a comment to communicate this to other team members. But of course, we are talking about open BIM standards here. So BIM collaboration format, or BCF, is the right way of communicating this information. So you go, you identify this topic or this issue, and then you create the right BCF topic in order to communicate that. You can also import a BCF with all of the information that I was saying before, assigned to the date, the stage, the priority, all of that, and you can see that including the viewpoint. So you can see and retrieve that exact view where that topic was created. And of course, you can share that as a QR code or as a URL with other team members. The other standard is the information delivery specification. So IDS is very important for us to do this to basically validate the models. So you can load the IDS in the BIM viewer, and you can verify really quickly which elements comply or do not comply with the requirements set in the IDS file. And of course, you can see that both in the data or in the 3D viewer to get that information and to be able to validate that. And again, share that information very easily with other team members. So yeah, that's pretty much what we have in the BIM viewer. And as I was saying before, everything really integrated in the GIS scene. So that's what we have right now. We're working, like, there are a lot of things in the roadmap that we are really happy to integrate in the next couple of months.
So what you've seen today represents more than a technical platform. It's a demonstration of what's possible in a group of individuals, commits to pushing open source technology to transform infrastructure management at a national scale. And we recently won the Professional Research Award at Building Smart International, which is very exciting. And the next exciting thing, as Nico mentioned, is the beta release, which we're scheduling probably in end of December. So this will make the core technology of our platform accessible to the broader community. And if you're interested in registering for beta access, you can go to our website, and we're going to be providing access to the beta community.
So yeah, please contact us or visit us at collabdt.org or use that QR code. And where you go to that website, you can add your email to the beta list. And as Laura was mentioning, this basically is the starting point, because once this thing is out, we hope that we create a framework or like an environment that will evolve more organically and that will bring us things that we are not expecting. But to start there, we need all of you to doing so. Thank you so much for listening.
Really,
The summit was held over 2 days, and the rest of the week, the other agencies were hosting meetings discussing some of the case studies that they have pulled funds for and how those are going. But when the summit opened up, it was an overview of the Building Summit International that was held, and some of the key points was, and that which was already mentioned, I think, before by Tony, is that China is leading the way in openBIM and these standards. In March of 2025, when it was held in Singapore, they swept all the awards. And the primary reason that we think that this is happening is that they have invested a lot of money, a lot of resources into upsourcing their talent, and they have a lot of training for them, and they're also sending them to conferences across the world. So they are putting a lot of investment so that their leaders can learn the new technology and bring it back. So they have a unified openBIM standard, which is being used along with an established CDE, which is driving savings up. So as you can see there in the slide, they've seen 34 million in cost savings in avoidance, the first 4 years. There's a 20% time savings from the manual information exchange, which is about $4 million. and a reduction of design checks, roughly 1.9 million. Next is Singapore. Singapore is also implementing this type of strategy and in upsourcing their individuals and investing in conferences, and they're quickly seeing some of the same ROIs as China is seeing. Open standards is something that has helped many of these countries achieve their success by developing standards and then defining how it's going to be used and implementing it across the nation. So having good standards is key to a successful project, and it also allows you to capture sustainable metrics. I have multiple screens here, so I don't know which one to click on. Okay. Next was followed through by the infrastructure domain, or Building Smart's Infrastructure Domain Steering Committee. This committee works to establish standards for data flow throughout the life cycle of an infrastructure asset. They discuss how IFC 4.4 is available now. It worked from IFC 4.3. It started from there, and through feedback of its users, it improved its application, and now 4.4 is out. While they're also developing the IFC 4.5 is under development as well. The IDSC is also working with other domains such as BIM and GIS to develop guidelines for use within those two agencies. So they have integration with different domains to see what the best use is for our industry. They're also working on an infrastructure domain guide so that it can be used throughout our platforms and within our divisions. The next steps for them are to use real projects and implement openBIM standards. Right now, where their standards are being used is within the transportation pooled fund, which I'll just cover up next. They're also working, or actually not working, but they mentioned that data governance should be a part of the digital delivery plan. Each agency should, if they haven't already, but start thinking of what their data governance is for their individual agency. Many times when I work on projects, I'm asked to write the data governance plan on a project, which should not be the case. It should really be the agency writing the data governance plan, which is your manual to tell your designer how to capture the data, how you, in what format you'd like for it to be delivered, and how it will be shared. And it's best that it's written by the agency rather than your designer. These are some of the tools that the group has developed. These are openBIM workflows. These tools are available on the Building Smart international website. You could use that QR link below, and it will take you to the web page. So there's the industry foundation classes, BIM collaboration format, information delivery, validation. All of these are tools that are meant to be used together to validate a design and help for us to deliver openBIM platforms. Now, openBIM platform, the main purpose for it is to not be tied to one software vendor, but to open this up for multiple vendors so that the designers can choose a platform that they're most comfortable in using and be able to deliver that to the agency as their formal deliverable within an ISC format. So the Transportation Pooled Fund is a collaborative research program run by the Federal Highway Administration and other parties like the State Department of Transportation, the DOTs. It allows organizations from multiple backgrounds to pool their funds and conduct research and address similar challenges together and avoid duplications of effort. So it's more of a lessons learned from one agency to another while sharing how they've captured or they've defined the problems and how they resolved them and share that information with other agencies. So 3 of the use cases that were discussed at the summit were, 2 of them were from PennDOT and 1 of them was from Iowa DOT. And obviously they're all based on bridges. They were similar in size. They weren't too complicated, 3-span, they had abutments. All 3 of these use cases used Bentley products to produce the bridge. So the goal for the use case was to deliver an IFC federated model with 2D documents. That was one of the goals. The second one is model as a legal document, meaning that that rather than delivering PDFs and CAD drawings, you'd deliver the IFC model, and that would be considered part of as your legal document. While within that, there will also be 2D views to help you understand some of the construction aspects of your project. So some of the challenges that all 3 use cases saw is in using Open Bridge Modeler, they saw limitations in the capabilities with object classes. So there were challenges when they were exporting the model through IFC, and they use IFC 4.3 for these exports. The models were not clean. They had to go use outside tools to clean up the models. They had to edit these IFC models to be able to meet the deliverable. Bentley worked with all 3 of these use cases in helping them to extract the data out of the software. And they also made upgrades to their software. But the key point here is the upgrades were only made to those who were working on the pooled fund use cases. They didn't push those updates across to the entire platform. So whatever was made customized was customized for those who were working on that pooled fund use cases. Iowa DOT took their use case a little further in where they integrated advanced digital construction management systems, or ADCMS as we like to call it. And the goal was to improve project management while using digital tools. Here they requested the model to be delivered as a legal document so that it could be the single source of truth to replace the 2D drawings and PDFs. So some of the challenges in doing this is in being able to build out the spatial structure on how to connect the different models into a federated IFC model, especially if they're being delivered by different contractors, or not different contractors, but different software types. So they saw a challenge on how to integrate multiple IFC models. In that image there, you'll see some of the different platforms that they used to be able to make the integration. So it's not one software that's going to do it all. You will need to have a library of software to be able to meet, to clean up the file, to integrate things, and to be able to share it. Right there as well as they develop custom IFC export tools out of OBM. And they also mentioned that the IFC file was not clean. So when they also engage the contractor in this use case, and the purpose to engage the contractor is to limit some of the past challenges that they've seen in construction. Some of those being to avoid increase in production costs, inconsistent data from different design sources, and as-built data being scattered and not delivered on time. At the end, they found that there were still challenges as seen by the previous agencies and their use cases. But the key takeaways is having IFC deliverables provide flexibility in the model development. There's no need to define one platform as a platform to be used within the agency. It's platform agnostic. They also notice that vendors want to help. They'd like to provide guidance within the industry, but they haven't done it in the past because we haven't reached out to them. So software vendors are willing to support our industry. We just need to engage them. The pilot project has enhanced industry engagement. So not only is software, but also multiple DOTs are now engaging with each other, sharing knowledge, reaching out to other agencies, and it's not strictly DOTs, but they're also reaching out to MPAs, and other even water and waste plant management. Let's see. So another challenge within the construction is a lack of support for them, whereas they do not have the tools that are needed for IFC adoption. Designers had used about 5 different platforms to make the conversion of this IFC model, but then when it's delivered to them, the contractor they found that they need to train their staff because their staff do not know how to use the new technology. It's either they don't know or they don't want to learn. But I think that happens if you're in design or in construction. There's people who resist the new technology, and also having the time to know it, because it's difficult to train staff as they're working. There was one more panelist there that provided a use case, which was Caltrans. I had to take a meeting at that time, but the takeaway with Caltrans, I don't have a slide for that, but I'll just talk about, is Caltrans is moving ahead. They're instead of using a use case, they're actually implementing it on their projects, and they have a data governance plan. Unlike the other DOTs, they are implementing ISO 19650. The other DOTs are looking at it, but they haven't necessarily implemented it. Caltrans is implementing it. They are slowly rolling it out to their project, and it's becoming a requirement for them. They are actively trying to push model as a deliverable and are requesting it on some of their contracts. Towards the end of the second day, what I found very interesting was when we had a panel discussion with contractors. And we had Kaufman, Ferrovial, Hewitt, and Granite be part of the panel. And here I'll list some of the questions that we asked. The first question was, what is the biggest challenge that you see with BIM data models? They saw the same challenges that we see in the design side is interoperability of the model with software that they use. Sometimes if they use Autodesk or, they might not work well with Bentley, and having to translate that data is challenging because you might lose data in translation. Or their staff don't know how to use a certain platform, so they have to figure out a way to get it into the platform that they do know. Models get distorted when bringing files from one platform to another. So this proves to the benefit of having an open source where we can deliver an IFC model and it be able to be open on any platform that is out there. Pipe networks, they see pipe networks as an issue when translating it from one software to another. I've seen this when bringing in from Civil 3D to Revit. If you try to bring it in natively, it is an issue. As I mentioned before, people not knowing how to use the technology. There's pushback from some of the more seasoned veterans, I would say, who would like to continue using their tools, and they don't want to adopt a new technology. This question, what legal and contractual challenges do you see with an MALD? One of the challenges that they see is to make everything transparent. They're not seeing that designers or even the agency is not sharing information as they should be if MALD is being a deliverable. And I see this as well on working on large scale projects where you even have a project manager overseeing everything and or PMC and trying to share information from one package contract to another package contract is challenging. No one wants to share information, but you need to because you have an interface and you need to make that connection. If you're not sharing information, then there won't be a connection from one tunnel to the other. So it is a challenge, but one way that they discussed is, writing it in the contract, or that there needs to be the interface and making everything transparent. The second response is must have a level of trust between owner and the contractor. Goes along with the sharing and being transparency. In order for us to be able to work together, we need that trust, not only with the owner contractor, but the designer and all the subs that are part of it, because we all have equal stake in the game. If we lose, one person doesn't lose, everyone loses. They also say that LOD is confusing. It needs to be clearly defined because there are some elements that can be delivered at an LOD 300, but perhaps utilities is all at a much lower level, LOD 2, or perhaps 100. So they see that if that is clearly defined and expectations are defined, that it's better for them, because one of them did mention that they still haven't closed out one of the projects, and it's been over 5 years because some of the elements they cannot make 300, and so they have to go back and forth with the client trying to figure out what the best resolution is for them. But LOD, defining the LOD and having clear expectations that meet the project deliverable. The last question I'm going to go through is, what are the goals for digital delivery? So they answered it in their perspective. So they said that they must try new technology to remain competitive. They can't remain using the same technology. And this is similar with designers as well. It's like we need to learn the new technology, the new workflows, and work with different agencies to be competitive within our industry. Train and support staff is challenging. At the beginning of this presentation, as I mentioned that, China and Singapore, they're heavily investing in training their staff, and that's one of the reasons they're becoming leaders in open BIM workflows. Using 3D models to make better predictions for other projects. So what this means is they're actually saving these models and using them to do cost estimates for other projects, especially by using the models and using software that can do cost estimating. They're able to then have a library of models and do better cost estimates for future projects. And they're also leveraging the data so that they could have metrics for their company to see where their shortfalls were, how many people were trained, any Power BI metrics that is possible, that's what you could use these 3D models for. And that is all I have for you. There were like the Astros and JSAN presenting out there, and what they were saying is, as an industry, we should go and join some of the national CAD standards, some of the agencies to help develop the standards and help move our industry forward, so that it's built off of the knowledge that we're bringing as subject matter experts within our rail or bridge industry, and build the standards so that we can move the nation forward and be as competitive as some of our, China and Singapore that are leading these open BIM and agent initiatives in their country. Thank you.
I guess as a closing out comment, I would say that it's been a remarkable year. This was the first year for the Building Smart USA Rail Committee. So we achieved a lot of firsts, I believe, for the USA Committee. This is the first independent rail day, and I would call it a success. So I would welcome everyone to have a well-deserved restful evening if you're here with us in the United States in this at evening, and for everyone around the world, thank you for joining us, and we hope to see you. We hope that you save the date and join us next year. Thank you.